Hello, we're going to be talking about production issues and the solutions that we came up with the issues that we faced with the assembly line. My name is Rola Hashimi, Jack Lowen, Stuart Rolston, and Mohammed Al Amir. So just a quick overview of the outline. We're going to be talking about the demand constraints, a quick recap, precedence diagram, workstations, solutions, results, metrics, how we measured the problems and the issues, improvements, results on improvements, comparison of the old and new design, total quality management. We'll talk about push systems and then conclude our findings. So the demand, our constraint, a demand of 5,000 flashlights per week. There are 8 workers per production line. Each worker was paid at an hourly rate of $10, and they work for 8 hours a day, 5 days a week. With these figures, we were able to calculate a takt time of 28.8 seconds. A quick product overview. The object that we're working with is a battery-powered hockey puck flashlight. To the right, you can see a list of all the tasks and description of each task. The front casing, the light cover, and power button were all assembled into the front casing as one unit, and then joined to the rest of the parts to conclude the production of the flashlight.
So here's an image of our precedence diagram that we came up with. These numbers correlate to the previous slide where the tasks were described. As you can see on the left, we also have a table with the trial numbers and the average times to complete each task. Using our calculations, we found that the K0 for this production line was 4. However, as you can see, 3.02 is barely over 3, which alludes to the fact that later on we could potentially get our K0 down to 3 workstations, which would cut our costs. So our initial results were we found that the assembly line was 88% efficient, and we calculated that our budget was $3,600 per week by using the number of workers, their hourly wage, how much they work, and we found that our assembly line only required half of that, which alludes to the fact that our budget was 50% efficient. The way that we measured efficiency was based on time and cost. Labor and machine maintenance were both issues that we had with time, so cutting down all of those would help with our time. Labor also, cutting down on that helps with our costs, and the manufacturing materials as well. So the main problem that we had with the assembly of the flashlight was aligning the small screws to the battery casing. Orienting the light cover as well and the cover glass on the front casing were issues. However, we found that orienting them before the actual assembly helped completely get rid of those issues. So in order to improve this task, we decided to align the screw holes flush to the top of the battery pack. After we did that, we found that an average time of 6.45 seconds was achieved, which is a massive time cut from what that specific task had taken before.
As for the design lean, So basically, we just decided to make things easier for us to have every single part in a bin, just so it can save time and make it easier for us to find the parts rather than having them all in one bin. As for the redesign production flow, uh, first we were working in a diagonal flow where parts were misplaced, some unfinished parts were taken and thought to be finished. However, we decided to go in straight lines and next to each other to make things easier and not to misuse the wrong part. As you can see here, this is the learning curve for task 5, which was initially 24.73 seconds. And right now it's roughly around 6 seconds, which is a massive decrease. And that was our old bottleneck. Now it's not. So the new assembly line consists of 3 workstations. Our new bottleneck is 12.9 seconds, which is a still like massive decrease. It's half, almost half. And 3 workstations all around the same time with idle time that could not be considered. Comparison between the old and the new quickly is mainly in the workstations. So 4 to 3, the budget usage dropped from 50% to 37.5%. So the weekly savings that we have is $450. Right here is just the first interpretation that we have for our diagram. As you can see in task 8, it consists of a task 8 prime of the new one plus the task 8 that we have. We had to split them in half because we couldn't fit task 8 in one workstation. This shows more productivity, and what we did shows more productivity and more efficiency. For production rates, overproducing and working hours cut down are major factors. So advantages of overproducing is just having lower cost per unit time, and you have a variety of products in the market. As for disadvantages is high inventory costs, and demand is not stable, or meaning it can go up or go down, and it will eventually affect your cost. As for working hours cut down, the advantages of that you can get the most efficient time out of employees because you give them less time to work. But you can still consider giving more hours to more efficient employees. As for the disadvantages is basically lower productivity because you're cutting down your working hours, and the cost will be higher because you have to hire new employees, and that affects the training process. Total quality management is basically customer and employee satisfaction, and it's focused on customer, employee involvement, and continuous improvement. Um, the customer is mainly wants a good quality of a product. As for employees, if you give them proper environment, they will meet the demand by having by being more efficient and more creative, thus having continuous improvement in the production line. Just in time versus material requirement planning is basically the post systems versus the push systems. The goal for each is lowering the inventory cost. However, for post systems, you only produce once you have a demand, and you always meet the demand, and you have to consider buffers. However, the push systems, it's for overproducing, or keep on producing until you find forecast, and you don't care about the buffers that you have.
So as you can see, this is a rough sketch of our initial brainstorm. As Stuart explained earlier, we decided to raise the elevation of the holes to be flush with the battery holder. That makes it easier to align the screws for the next workstation. As a simulation, we use straws and cut them to the height that we wanted and place them above the holes in order to simulate that elevation with the piece. The next few slides will demonstrate how we put together the pieces along with the tasks and the workstations. As you can see, the first station there is assembling the glass cover onto the front casing along with the battery holder and the power button. Workstation 2 is the workstation, or the task I should say, that gave us the highest bottleneck, which we improved. That's aligning the screws into the battery holder. As you can see, it's quite tedious and takes a decent amount of time just to get the screws on, right? Task 3 is post-aligning the screws. The employee will fasten the screws into the battery holder. Following that, as you can see, he'll place the batteries into the battery holder. Little mix up there. All ready to go. The last and final workstation in our initial assembly consisted of putting the back casing on and fastening the big screws to complete the part. As you can see there, he's fastening the 2 big screws using the screwdriver, and the part is complete. So this is the improved workstation 2. As you can see, it's a matter of seconds and the piece is done. That was using the straws, of course, putting the screws into the straws. As you can see, it took 5 to 7 seconds, along with the bin there prepared for them, all ready to go. So we cut that down from 24.73 seconds to, as you can see in the video, it's roughly 6.5 seconds at most. In conclusion, our old assembly line had a bottleneck of 24.73 with 4 workstations and a 50% budget. Although we did meet demand, improvements did enhance the way we could assemble the part. We cut down 4 workstations with the new assembly down to 3 workstations. Due to the fact that the 24.73 for task 5 is no longer our bottleneck, we have a new bottleneck of 12.9 seconds, which in the previous video was putting the back casing on and finishing off the screws. With that being said, less workers, less stations means less budget. So we only use 37.5% of our budget and continue to meet demand. So you have another option where you can have 4 workstations with the same budget but overproduce, and that all pretty much depends on the client and what they're trying to minimize or maximize. Depending on your inventory holds, how much it's going to cost to hold inventory, you might choose to have 3 workstations and produce the demand that is requested, or have 4 workstations and overproduce. With overproducing though, you might have employees that are off for a certain period of time, and they might look for other work, which will increase your turnover rate, which then goes back to what Amir was stating earlier with the 2QM. So therefore, you can see the improvement on our design helped sufficiently decrease our budget and our takt time.